Hello and welcome to my channel Flexo Master. Today we are going to study digital photopolymer printing plates. What are the stages in plate processing of digital printing plates? Then we have linearization, focus test, stain test, then bump up curves and so on, measuring the plates and so on. So we will continue. So here we start digital photopolymer printing plates, chapter number 9. We start with the introduction. The digital photopolymer flexographic printing plates imaging uses no film. Conventional plate making generates chemical waste from film processing and solid waste from the films. Multiple generations of films are usually produced during job approval and for conventional analog proofing. Digital plate making only generates a thin black integral mask as waste. It promotes the transition to an all-digital workflow that employs digital proofing for job approval and final proofs. For digital photopolymer plates, a photo tool is created directly on the unimaged photopolymer plate surface from a black layer that is manufactured on top of the plate. The black layer covers the entire plate. It absorbs ultraviolet radiation like film, and it also is sensitive to infrared radiation. An imaging device, much like an image setter, uses a high power infrared lasers or lasers to remove the black layer corresponding to the image to be transferred to the plate, revealing the unimaged photopolymer underneath. The removal process is called laser ablation, and it creates the photo tool or integral mask. The underlying photopolymer does not absorb the infrared laser radiation. Thus, it is not affected by laser ablation. How the digital photopolymers looks. On the top, you have a protective foil which you will remove while you are ablating the plate. And this is the laser sensitive bullet mask and photopolymer polyester base, and this is UV sensitive photopolymer. As is shown in the above figure, the primary difference between a conventional flexo plate and the digital flexo plate is digital plate has a laser sensitive mask only applied to the surface of the plate during manufacturing. The purpose of the mask is the replace the film used in conventional flexo plate making instead of sending screen data to an image setter to create a film for plate making. The digital plate is loaded onto a Flexo computer to plate CTP imager, and the screen data is sent to the laser which ablates the mask and creates the desired image on the surface of the plate. Then the plate is then removed from the imager for exposure and processing. The main UV exposure is performed in the same manner as in conventional flexo, except the laser sensitive black mask is performing the job of blocking the UV light. These are the stages in processing digital plates. Digital flexo plates with black mask coating, UVA back exposure, the second step, and the third step is CDI imaging for the main. Then you have two systems for conventional solvent processing. Okay, then you have another processing system which is thermal dry processing, and you have UVA main exposure. Then I will show you that actual making digital flexo printing plates, which covers digital density, linearization, bump up curve. Back exposure test. Let's assume for plate thickness you have 1.14 millimeter. The back exposure time is 40 seconds, which is 14 milliwatt per centimeter square. This is the measurement when you measure the UV intensity for your main exposure unit. Example, when you measure the intensity of a UV lamps in the exposure unit, presently 17 milliwatt per centimeter square. Therefore, how can we calculate the required back exposure time? Now, the calculation is here below. You have to apply in the formula what you are using for your existing time before, which is 14 milliwatt multiply by 40 seconds you are using before and divided by present intensity what you have measured. Then if you calculate, it will come to 33 seconds. So therefore, your back exposure time should be 33 seconds. The next step is back exposure test. First, you have to check out lamps output always in exposing unit. Second step, plate surface to identify in digital plates which one is for the back exposure and which one is for the main exposure. The third point, plate back exposure test, times in seconds. You do the test 30 seconds, 35, 40, 45. Then the next step is that you have to check the focus search strip test in the CTP. So remove the protective film or cover sheet from the plate, mount the plate on the CTP drum, then you perform focus test. The laser should stop upon the carbon mask. How you will do is that the measurement 2 millimeter in width and 3 centimeter long lines which you have to input. Then you run the TTP for searching the focus search. When you have finished the focus search strip test, now you have to check and measuring. You should have a light table, put on light table and check with 100x magnification. All the lines are in different thickness. One line is thin, check the thin one line. Which is the thinnest? Count from the beginning up to the thinnest line. Example, no number 5 line is thinnest. Then you enter number 5 in the screen or focus test in the CDI, CTP. Alright, these are the instruments used. This is light table and the microscope for 100x magnification. The next step is that stain test. Like film, density values of the carbon mask play an equally important role. If a digital mask density is too low, pinholing will occur because not all light is being blocked by the carbon layer. Likewise, if the carbon mask has a high density, it will prevent the laser from properly ablating the digital mask. If an area of plate is not properly ablated, it will hinder exposure, causing malformed dots. Number 1, remove the cover sheet of the digital plates. Number 2, using a calibrated transmission densitometer, zero out the device to the raw photopolymer plate. Measure the digital plate carbon side up using the density function with transmission densitometer. Number 4, the digital plate should read a value between 3.5 to 4.25 density because the density is a logarithmic function. The difference between a 4.25 and 4.3 is minimal. However, if you measure a 4.5 or higher, take a note. The next step, interval. Interval means how many times in a week or how many times in a 1 month you have to do the inspection. Minimum 1 per week and when visual inspection fails. The tools which you have to use is transmission densitometer. This is available in the market by a famous manufacturer, Tecon, from Germany. And how to do that? As I explained you, put the plate and run it. Peel mask off with tape. First step, zero densitometer. Then measure 100% patch B less than 0.07 for 100%. Okay. The third one, measure 50% patch. The next step is C, which should be 0.3 plus minus 0.02 for 50%. The next step is linearization. Linearization or calibrating the ESCO CDI is uh, properly is done through a process called the stain test. ESCO will provide all tools necessary for task minus the digital plate. There are two variables that can be changed to alter laser power, that is wattage and revolution per minute RPMs. ESCO prefers to ablate at full power and alter revolution per minute, as well as consult the CDI manual to establish limitations of RPMs for plate gauges. Thicker plates must be run at slower RPM than thinner plates. Mount a back exposed digital plate on the CDI. The first step. Second step, find the test target. Provide ESCO has 50% tone and 100% tone. Ablate the target from 2.2 to 4 joules per centimeter square in increments of 0.0 joules per centimeter square. Number 4, step and repeat each target 3 around the plate for a good sample variance. Make sure that after ablating the test target, remove the plate from the CDI and take a piece of tape to remove a section of the carbon mask. Then, when you remove the carbon mask with the tape, using a calibrated transmission densitometer, zero out the device to the raw plate, photopolymer plate. Then, how to measure it? 100% must be 0.2 to between 0.07, and 50% measurement must be between 0.28 to 0.31. If suppose in 50% found the reading 0.33, then to control a speed of drum 700 revolution per minute, then the power of laser should be 20 watt, assuming between 11 to 20 watt. New test, speed of the drum should adjusted from to 650 rpm. It is advisable to play with the drum speed. If suppose in 50% found the reading 0.26, then to control speed of a drum 750 rpm or 800 rpm. Hope you understand the measurement. Bump up curves. Good plate making condition, correct power settings and bump curves will eliminate malformed highlight dots in plates. Step 1. Using the established power settings in the stain test, ablate the ESCO test targets and the customer's specified lines per inch dots. Expose and wash out the ablated plate. Allow the plate to properly dry. Using a 100x power microscope on a clean light table, note the form dots for each line screening measure 0.001 inch through the backside of the plate. Apply the bumps to a newly created file. Update the new file and create plates with the same condition to confirm a correct bump curves. Now the summary. The summary is that the Flexo plate media generally have limited highlight resolution because half-tone dots become smaller in highlight area. A point is eventually reached where the half-tone dots no longer develop properly. This is caused by insufficient UV energy reaching to the plate. For Flexo plate digitally imaged on any imaging device, the effect of oxygen inhibition during UVA exposure causes the dot on the plate to be smaller than the exposed mask opening. For instance, the size of the mask minimum dot may be equivalent to a 5% dot, but the size of the resulting dot on the plate must be as small as 1% due to the effects of oxygen sharpening. An experienced media representative must perform systematic exposure tests to establish minimum plate exposure values. It is not the responsibility of any one specialist to determine minimum exposure values, but those values must be established before the specialist can proceed with implementing Flexo screening. Without a screening technology, it is necessary to have a strategy for dealing with the values below minimum dot value. Traditionally, a bump curve is applied to put output adjust values that are below minimum dot to force the smallest half tone dots to print at the minimum dot value or higher. Hope you understand this chapter, and thank you very much for giving your valuable time, and we will move forward. Okay, so I will continue more in the next videos. Till then, I like you to share, like, and subscribe my channel and to learn more and more. Thank you very much and goodbye.